Rich Worsbach. He is the president of MRG Labs and has over 30 years of experience in the development of condition-based maintenance programs. He's also certified in the ICML as a machine lubrication engineer. He's also an active member of the ASTM and Inservice lubrication group. I also will be introducing Chris Orr, who's from ES3, and he is available to answer some questions today as well. Chris is the supervisor of the automation and reliability. He is responsible for running lubrication laboratory as well as other reliable programs like IR and vibrational analysis, and he is certified in LLA 2. So thank you, Rich and Chris, for joining us today, and I'll turn it over to Rich.
So I did load this in here, and I see that I can't run some of the videos that we have for this. So I'm going to do a share screen here to bring up the live version of this presentation, because there's some neat videos here, and I want to be able to share them with you. So first off, I'd like to acknowledge the contributions of Richard Janoski, our lab manager, who worked together with Chris Orr at ES3 to do some field work to support this presentation. And I'd like to thank Chris for coming to join us today. And Chris, I may call on you to have you input on some things, and especially to answer any questions that might come up. But let me get us started here by talking about using grease analysis to monitor the cleanliness of new greases. And so, we can ask this question: does grease cleanliness matter? And certainly in the context of oils, I think it's pretty well understood now by most asset owners that oil cleanliness is critical. It impacts the life of the component being lubricated, and it also impacts the life of the lubricant itself. And even though that's well understood, and we have folks that are working hard to procure clean oils and to keep them clean and to filter them when necessary, grease often gets overlooked in this regard. But wear in grease is cumulative. So we have to start clean. We have to have grease coming into our machine that's clean to begin with. And that's really going to make a big difference in the life of those components from an abrasive and fatigue standpoint. So just to kick us off here, we're starting with just this illustration of, what does clean grease look like and what does dirty grease look like? And we're taking advantage of an ASTM standard method. It's ASTM D7918, which is an integrated tester method, which tests 6 different parameters of grease. But one of those 6 parameters is the grease particulate cleanliness. And it's tested by using a video, a magnified view of the grease in a thin film presentation. And so here you can see what this looks like when you have a fairly low particulate population in grease, as evidenced by the 1 milligram per gram image at the lower left. There's still a few particles there, but it's relatively low. Then you have the 10 milligrams per gram, and you've got 50 milligrams per gram. So these are greases that we were able to kind of get and present to see what those differences look like from a video perspective. And certainly, as you look at that, you can ask the question, which of those greases do I want lubricating my critical machinery? And I'm sure everyone would agree that, the one at the lower left or even better than that would be ideal. So what are some of the best practices for grease storage? Well, lubricants in general should be stored in a cool, dry place. We can add clean to that as well. The use of labels to clearly identify the products helps reduce the chance of mixing up, grabbing the wrong product, or even some contamination in a physical or a vapor type of situation can be eliminated or minimized by keeping things separated, well labeled, and in a clean and organized location. And then the grease guns that we use should be stored to prevent contamination and leaking. And that's another thing that we want to talk about. So we've got some pictures that we were able to get shared by the folks at ES3, and I just got to compliment Chris and his team on the attention to detail that they've given to their operations to really look at it from end to end and identify where contamination can enter the process. And as you can see here, creating a very clean, well-labeled, well-lit environment for storing of lubricants, both greases and of oils. And we have that represented here. And it makes a big difference downstream. In other words, where are these lubricants ending up, and what's it going to mean in terms of any contaminants at all that might get into that process? The better we can do at keeping them clean, the better performance we're going to have from our equipment. So if we want to monitor the health of grease, it's really going to help to sample that grease. And again, historically, it's been a bit of an oversight. There may be historical efforts to generally try to keep things clean and well labeled and so forth, but not so much on the testing side. And so that's what we're here to talk about today. What can we learn by sampling and analyzing our greases, and not just the grease out of the machine? We're going to talk about greases in storage when they're first procured, and throughout that process from when they first show up on site to the point at which they're actively lubricating our machinery. So routine sampling of the baselines or of the new greases helps us to identify contamination issues in that new supply chain before the grease gets deployed or used, and ensure that clean grease is being added to our critical assets. Because unlike oils, we don't have the opportunity of filtering after the fact. There is not an effective way of filtering down to the efficiency necessary for finished greases because of the disruption that could traditional filtration would do to greases. It would disrupt that thickener and change its properties. So we're kind of stuck with what we've got. And therefore, looking at the new grease and looking at how clean it stays in storage and in being transferred and being loaded into grease guns is really critical, because we don't have that opportunity to later compensate by filtering out any particles, any moisture that has accumulated. So we can start by sampling from grease drums or grease tubes. We can do that by pumping directly into a syringe from a loaded tube, from a grease gun, from a drum, through the dispensing pumping system. Or we can use a grease thief or a grease thief with a T handle or a slim handle to core a sample. And that way we can look down through the body of the grease, not just the top surface that we might access by taking off the cap or opening the lid and so on. And we can also use a spatula and syringe to kind of load that up. But you can see here a picture of the syringe that would be part of our typical grease thief sampling kit. And in this case, maybe using something like the pillow block kit. And we don't have necessarily a kit that's custom built for new grease sampling, but we have in the past. We've done that for some special studies. But really, our pillow block kit could serve this very purpose by having the tools that you need to grab that sample. So you can see here the syringe that comes in a grease thief pillow block kit. We're just putting the tip of the grease gun right in there, pumping it full of grease, and then using it to transfer to the grease thief where we can do the subsequent testing. And then once you have it in the grease thief form, you can use the D7918 to, number one, do a dye extrusion test. And that dye extrusion test is going to monitor the consistency of that grease. And once we establish what a new grease baseline should be, perhaps, getting some straight from the manufacturer, establish what that is, and then maybe compare that to grease that's been in storage for some extended period of time. Or perhaps we find some storage containers that raise concerns about the condition of the grease. For example, if you store grease tubes incorrectly on their side or upside down, you give a path for separated oil to leak out. And sometimes you'll see this in the cardboard container. It gets saturated with oil, and it raises the question now, just how much oil has been lost? Does that compromise the condition of that grease? Is it, it's obviously changing the ratio between the thickener and the oil that's in that grease, but is it so much that it's going to negatively affect its rheological properties or its flow properties? And so dye extrusion can be a test that helps us monitor the quality of stored greases to see if that's changing. Second thing we can do here is after or while it's being extruded, you can see in the picture here that it gets extruded out as a thin film, and that thin film can be made to pass over a light source that sits behind this thin film substrate, and a high resolution camera that you can see right above this can be there to count the particles and monitor for contamination. So I want to share here briefly some work that's been done, some studies. This one study here was published in the NLGI Spokesman. That's the National Lubricating Grease Institute. And it's a study of the in-service grease testing techniques that can save money and time for grease manufacturers. Is how it was presented there back in the study that was published in December of 2018. And this is a study where we had some participants in various industries using different kinds of greases in different locations in their facility. And so I think I can kind of blow up this chart to give you a sense here at the lower left of what kind of greases we obtained for the study through these participating asset owners. Some samples that are represented in blue here were taken from new packages. So basically unopened tubes and unopened barrels of grease, opening them up and taking samples, and then running this test that we showed here on particulate cleanliness. And so those were the blue ones, which were the new greases. The green ones, which we got a few of them, were from grease guns. And then the yellow represented here was coming from the equipment. So we sampled from the new unopened packaging from the field deployed grease before it had been utilized. So it could have been in a grease gun, it could be in a auto luber or what have you, because that's another opportunity for it to get contaminated. And then finally looking at the, what it looks like in the machine. And interestingly here, we see an incredibly wide range of particulate populations. And I'll just take us now to the, let's go back here. Yeah, an incredibly wide range of the particulate population, even among the new greases. And you can see here we have greases that are extremely clean, down to 0.07 milligrams of a particulate material per gram of grease, which is just, there's almost nothing to look at when you represent this, up to something that's quite dirty, and actually dirtier than some of the used and in-service greases that we saw. So what we're finding here is that even new packaged greases can have, and we're talking about an order of 100 times different, 100 times more particulate in some new greases than other new greases. And that can definitely be of concern. And, I presented this at a conference and somebody said, hey, tell me the manufacturer of that grease A, because I want to know who I should be buying the grease from so it's super clean. I said, well, I could do that for you, but I'd also have to reveal that grease I was the same manufacturer. So it doesn't really, necessarily go to the manufacturer of the grease. It actually has a lot more to do with the handling process, how the grease is manufactured. Some greases are manufactured in open kettles, which means there's an open lid and the grease is potentially exposed to ambient debris while it's being manufactured, whereas some other greases are closed processes. Maybe the containers are kept cleaner. Bottom line is, if we don't test, we don't know. And I will also say that the greases here that had higher levels of particulate showed no visible indication of that debris. This is all small microscopic debris. So you can, we think about oils, and if we got really dirty oil and we get down to the end of that container, we might see a ring of dirt at the bottom, and that might tip us off that, wait a minute, now we got a concern here. But particulate and grease stays in suspension, and there's no way visually to extract that and see that except through a method like we're showing here, which is this visual magnification and representation. There's also another tool, a couple tools out there that folks use in the field, including the Hegman gauge. And there's a 1401 test that allows you to put your grease between two plastic plates and rub them together under pressure and see if the plates get scratched. But we're sharing here this method that allows us to visually see and to count in these particle ranges of what we have from a cleanliness perspective. The other part of this study looked at moisture. And again, we've got, I'll represent this table here so you see the different greases. And it's polyurea, it's aluminum complex, it's lithium grease, it's calcium sulfonates, and across the board. And it talks about some of them are food grade, some are high water washout, some are electric motor greases, and so on. But really across the board, you've got, again, this huge variation from greases as low as a couple hundred ppm to new grease with up to 15,000 ppm moisture, and and everything in between. So now, having said that, there are some studies that show you that how significant is that moisture? It depends a lot on the grease and somewhat on the application. Some greases are formulated in a way that they can tolerate a lot of moisture, and the top one in this here, the calcium sulfonate carbonate complex, is one of those greases that some studies show that can continue to lubricate surfaces effectively even into higher moisture levels. But not all greases can. And just knowing what my new grease looks like and how it is in the field, I'd just like to point out that when you look across here, the in-service greases actually, on average, have a little bit lower moisture than some of these new greases, and that might be due to once that grease that has a higher moisture starting point gets into service, that the heat of the and mixture of the operation may drive off some of the moisture that's there in the new grease. But think about this for a moment. Some greases are made from a soap thickener, and these soaps, in the manufacturing process of the soaps, the byproduct of that soap manufacturing is water. So you actually generate water, you create water as you're creating the soaps that are used in thickeners. And there are efforts then to dewater and drive off that moisture. But if it's not done effectively, if there's some shortcuts taken, if there's some production pressures and so on, that moisture, that residual moisture that's there because of the makeup of that grease, can be quite high. So this is a way of being able to test this. And while we're focusing mostly on particulate in this discussion, moisture is another thing to think about. In this case, we're again using D7918 and using a method that allows us to detect moisture down to the ppm level. Now, we think of Carl Fisher as being the gold standard for oil analysis for precise determination of moisture. And it can be used for greases. There are some interferences with that method. It has to be, grease has to be carefully prepared to get an accurate representation. There has to be some recognition that moisture tends to have varying degrees of adherence to the grease, or due to polarity, it may be kind of stuck in the matrix of the grease, and just kind of normal liquid approaches to heating a sample may not be adequate at driving all the moisture off from the grease when you're trying to measure it. We use a method, a device called the Vapor Pro, and that Vapor Pro device, with the proper configuration, does a nice job with a thin film of grease of transferring it over and giving us a very accurate representation of the moisture level. So I want to go now and take a look inside a facility, and this is the ES3 facility. Chris, are you with us here? Are you able to unmute and kind of join me for this discussion?
Can you hear me all right?
Yeah, I can, Chris. Hey, Chris, thanks thanks for joining us today, and thanks for, kind of opening your doors to give the folks here an idea of what it's like to be out in the field and in an asset intensive work environment, where you've got to fight the realities of the day to day issues here to try to get clean lubricants. So Chris, thanks for joining us here.
Yeah, of course, happy to help.
So I'm going to let's see how I do this. Here we go. I start this video on the sample collection. And Chris, this is you and Richard Janoski grabbing some samples, right?
That's correct.
So you have some color coding going on here with your grease guns?
Yes. So in the automation side, we have 3 different greases across the 2 teams. So we use a red, blue, and purple color code to make sure they're always using the correct one.
Great. And this one's actually a white grease or a almost clear grease coming out, isn't it?
Yeah, and that's part of why I think the color code is so important, because that same grease used to be red, and then Mobile changed the color of it, but our color code never changed for the grease gun and for the lube maps on the equipment. So they're able to still use the correct grease.
Right. So you had established a process, a color coded process, so they knew which grease gun to grab and where it should go.
Correct.
Yeah. So here we have, kind of showing what happens in the extrusion with the extrusion of the grease thief that the sample is taken in, but really just showing here kind of the process of the looking at the substrate and using this light illumination of the particulate and looking at using the camera to kind of represent what we're finding there. So this is kind of a unique way. Again, this is this ASTM standard, this D7918 method using the grease thief analyzer. Now you can see this is the moving that substrate along, and as you have that movement, then you can represent some volume of that grease as it moves side to side, and as you count and accumulate the particles. And we put them into size ranges of greater than 10, greater than 25, and greater than 80 microns. And this also happens to correspond to, this Hegman gauge that I mentioned and other methods for looking at. And this is the actual substrate that you see going by. We can see a few particles here, but all in all, it's pretty clean. Now, those big circles could be little air pockets in the grease. You do have some particles here, but certainly you can count them up and kind of assess it, and we'll look at that in a minute. Now here's Chris's red grease. And again, you've got some background coloration there, a few particles, but again, not too much. And here's our nice white grease, which gives us a good palette, and a few particles here and there. You're never going to get zero, right? In the real world, you're going to, and to be honest, even in brand new greases, you're never going to be at zero. You're always going to have something. The important thing is to quantify them in a representative manner, and be able to create criteria about that, and to say what's acceptable and what would not be considered acceptable, and then ensure that we can take some action to protect our grease supply. So there's what we saw on those 3 greases after sampling them with Chris in his facility. And here's the analysis. So we brought them back to the lab. We were able to do moisture testing. These moisture levels are actually pretty good here for what we typically see for greases. Chris, can you comment on what types of greases they were? It looked like maybe that third one is a food grade grease. Are these, the polyurea thickener or something else? Can you comment on them at all?
So the red and the white greases are both lithium based. They're Mobile Lith products of 2 different viscosities. And then the blue grease is a polyurea electric motor grease.
Got it. Okay. So yeah, and when you saw the study that we did, obviously you saw moisture levels much higher than this, and these are kind of in the range of what we expect, and there's a certain tolerance of greases, even in these, lithium greases, for some moisture. So in general, I'd say these from my experience, look pretty good as far as that goes, and they might just be representing the typical, again, Chris talked about being lithium complex greases, and that complexing process, that soap making process, does generate some moisture. The grease manufacturer is going to dewater some of that as part of the grease manufacturing process, but there is going to be some residual there. The important thing is to find out what it is in your supply, to create a criteria around it, and then to know when action needs to be taken, because maybe every once in a while some grease will come in, maybe it was exposed outside before it got there, and so on, and you would want to be able to intercept them and make sure that you're only using clean, dry greases. But let's look at the particle count here. I mentioned the greater than 10, greater than 25, and greater than 80 micron size ranges. And one very promising thing here is you don't have any big particles here, Chris. It's you got 0 for the greater than 80 micron, and that's real good. But even the numbers for the greater than 25 and greater than 10 are quite low. And you can see that for the polyurea, since the greater than 10 and greater 25 are basically the same number, that means that they're somewhere in that 10 to 25 range. So they're on the smaller side here. So our assessment for these is that we would classify them as very clean relative to what you typically see for new greases. So this is a promising thing. It does a couple things. Number one, it helps someone like Chris and ES3 to understand their grease supply. And when we think about grease supply, we want to think about the manufacturer, but we also want to think about the distribution chain that gets it to our facility. There's a lot of handling along the way, and if greases aren't carefully protected in that supply chain, we could be seeing some contamination issues. So right now, for these greases, things are looking pretty good. Low moisture levels, very clean particulate levels, and that has to be, really reassuring for a company like ES3. But it can be helpful too to spot check this once in a while, and to make sure that we continue to get that good supply of clean and dry grease. Now, I'll give you another story here to back this up. And a while back, we were asked by a grease manufacturer to test one of their customer samples because they had been having an issue with that. And this customer was questioning the grease supply, whether the grease was the problem. So we received a sample. We weren't told really anything about the equipment that it was coming from. But we were asked to test it and to tell them what we would find. And when we looked, we found a high level of wear, of ferrous content in the grease. And when we looked at it under the microscope, we found that these particles corresponded to gear wear. And we reported that to the grease manufacturer, and they expressed real disappointment in our assessment. They said, we thought you guys knew what you were doing. But this sample did not come from a gearbox, it came from a bearing. And so we requested a follow-up, and we said, can you send us the new grease from your facility that these guys are using? I just want to do a reference, make sure we're doing a good job here, and we have it referenced to that new grease. And we got that new sealed grease from the manufacturer. We tested it. We also found high ferrous wear. And when we looked at it under the microscope, we also found a gear wear. And here what was happening was that facility at that particular point in time was experiencing a failure, an in-process failure of their grease transfer pump. So the grease transfer pump that was taking it from their manufacturing kettles to the packaging line was actually failing. The gears were failing, and it was generating gear wear and putting these gear wear particles into their new supply of grease. So kind of an extreme example, but it underlies the point that it doesn't help just to assume everything's okay, that the greases that we buy are clean and dry, and testing can help us understand that and reinforce that. So here's an in-service grease, and you can see the difference here on this representative picture, the snapshot picture. You've got some big particles here. You got some big curly particles. Now you are not only looking at the particulate, the dirt, if you will, that got into the grease, or the manufacturing debris that got into the grease at the beginning, but now you've got the added element of wear taking place, and the contaminants that are able to enter the grease as a matter of the operation of the equipment. So you add that on top, and you can see this is much, much higher levels. We went from just a gram or two of mostly 10 to 25 micron particles in Chris's new greases to here, over 50 milligrams per gram of particles greater than 10 microns. So we call this marginally dirty. We kind of expect this to happen over time, but the other thing is this can help us understand when does grease need to be replenished. Okay, and part of that optimal grease replenishment is going to be how long does the grease live from an oxidative perspective? How long does it last from an additive perspective when the additives become depleted? How about its consistency changes? But another one is the accumulation of particulate over its service life. And by looking at a sample after it's been in service for a known period of time, we can look at this level and say, you know what, if we have new clean grease that we validated and we know we're going to pump in its place, we could purge this grease out and we can reduce the amount of self-building wear. That is the wear that gets generated from wear particles that build up over time, because grease is cumulative. It generates wear with every revolution of the shaft, and it has no place to go. There's no sump for it to settle out in. There is no filter to take that particulate out. So it builds over time. So one of the key functions of grease in terms of our replenishment frequency is to clear out that accumulated debris and accumulated particulate that either came from wear processes or just from the dirty environment we're in, and just flush that away. But of course, that strategy only works if we have clean grease to take its place. So, Chris, I first want to ask you, do you have anything that you would like to additionally comment or bring up or talk about this experience you've had here and some of the stuff that you've been doing in your facility?
Yeah, the one story I thought of was when we first started doing oil analysis on site. We started testing. We were coming up with what our thresholds were going to be to do an oil change for cleanliness. And when we started testing our brand new drums, we found that they were already far above that threshold, which is when we started buying filters and filtering the oil before we even gave it to the technicians to use. And I think this just helps to highlight that it makes just as much sense to do the same thing for grease. Obviously, you can't filter it, but knowing that it's clean before it goes in is just as important as it is for oil.
Yeah, so I'll ask you, you obviously got some good news when we looked at these greases with you, and at those levels of moisture and particulate, it doesn't require action, and it reinforces for you that you're doing the right thing, that you have a supply chain that's getting you clean grease, and you can feel confident when you're purging out your machinery that clean grease is going in its place. But what actions would you or could you take if maybe, let's say, the red grease had a high particulate level, or the white grease had a high moisture level? What would you be thinking about doing then?
So what I imagine I would do, having a pretty good relationship with our vendor, would be get in touch with them and see what availability they have to maybe talk with Mobile on our behalf, which would be this manufacturer of our particular grease. I'm sure they have lot numbers attached to those tubes that they could find out, exactly when it was manufactured, which of the 100 different plants it came from. I try to work it back that way.
Yeah, no, I think that's a great approach. And certainly if we want to do this, we want to be, economical with our resources and the cost of doing this kind of testing. And so in some regard, it makes sense to do exactly what you did in the video here, which is to go to the point of dispensing, go to the tip of the grease gun. Because if you look at cleanliness there, It's actually cumulative of all the processes back in the line, which started at the manufacturer, went to the distributor, went into the storage process, went into the loading of the grease guns, right? You know, when you're opening up the tube and putting it in the grease gun, it goes to the cleanliness of the grease gun itself. So all that is cumulative. And so when you got these results, which is at the tip of the grease gun, it kind of validated the cleanliness of that entire supply chain and handling chain, right? The handling chain is on your end, right? Once it gets to your facility, how do I handle it? How do I distribute it, and so forth? It kind of validates that whole thing. But another thing to think about, if you're at the tip of the grease gun and you do see an issue, may want to do some sampling to kind of go backwards in the process, right? Go back to, you know, the grease guns and look at the grease guns. Look at the tubes themselves that you're loading in. Go back to that drum that you showed, which you're doing some, some larger volume automatic dispensing from. I know from having done a lot of audits, site audits, lubrication audits, that some of the storage practices I've seen have been pretty alarming. I do remember in particular one power plant, was a coal-fired power plant I worked in. And I showed up and I said, hey, can you take me to your lube oil storage facility? Where in the plant you put all your lubricants and then, in drums and things, and you then take them out to the various machines and so forth. And so he said, yeah, follow me. And we walked right into the coal handling facility, and right under the coal elevator, which is a conveyor belt, an angled conveyor belt, carrying this crushed coal dust. And it was underneath that their lube oil storage facility was. And while we were there looking things over, someone came in from the field, took the lid off of a great big drum of grease, plunged their grease gun into it, filled it up, and then roughly put the lid back on. And I went back over and looked, and you could see a layer of coal dust accumulated on the top of that new grease container in that facility. And I knew then that, every time they went out to grease something, they were greasing it with a slurry of grease and coal dust. And as you can imagine, that's equipment's not going to last that long. So that's the other piece, right? Is to, if you do find an issue at the tip of the grease gun, or if you have auto luber systems, whether these the single points or whether it's like a distribution system, go to the end of the distribution system and undo that delivery right at the nozzle or the injection point, and have that pumped into a grease thief to test it there. But it gives you the chance to work back through the system and find where those issues are. So I think you bring up a good point about partnering with your supplier and having them be an agent of addressing this. And I think that if you have more than just I don't feel good about the supply, I think maybe it's clean, I don't know, versus going back with some of this data, right? Going with those pictures that we saw, or even those little videos of what clean grease looks like and what dirty grease looks like, could really help to charge the interest in addressing it. So great thoughts there on the action that we take to address it. I see a couple questions coming in. I'm going to open these up now and see what we have here. I think Werner is the first one, and Werner asks, what is the difference in cleanliness and moisture content of a sealed bearing and grease from a drum? I think that's a good question. So sealed bearings, I guess we never get to look at that typically until there's been a failure. And certainly in our facility, that's been something we've looked at, is to look at the sealed bearing. And then the question becomes, if there's particulate in there, was it there with the new grease? Was it did it get in there because the seal was compromised in some way, or what have you? So it's a tough one to figure out. But certainly, if I have critical application where I'm buying sealed bearings and I'm not getting the life that I expect from those bearings, maybe pulling a few to look at what is the cleanliness inside those intact seal bearings could be a thing to do it, or just buy some seal bearings and test the grease from them, and maybe you find some particulate already there. Any thoughts on that, Chris?
No, nothing additional for me. I think you summed it up pretty well.
Good. David Turner says, how does this type of testing compare with the federal standard 791D method 3005? Yeah, so David's referencing a test here that involves taking some grease, putting it between two glass plates, and then using kind of a manual microscope method to identify, to count, and to size the particles. I think I'm describing it right, David. You can correct me if I missed anything on that, but that's my understanding of that particular test. And it is a test that's it's being used at different like military applications and aerospace applications, where there has been demonstrated that you really need really clean greases, especially like aviation instrumentation, where even a slight amount of particulate contamination can really have problems there. But this method is now I think the measurement methods here are quite different in terms of how it gets categorized. So David clarifies a little bit. There's no top plate, just a template to get a consistent thickness. Okay, so it allows us to get that thickness of grease. I think, David, there's some real similarities in the approach, the preparation approach, because with the grease thief analyzer that prepares this thin film that we saw on the substrate, while it's not glass, it is a transparent plastic, and it's laid on about 1 millimeter thick. That's the thickness of that substrate, of the film on that substrate, and then using lighting and using essentially an automated microscopic approach, the particles are identified, sized, there's shape information and so on. So I think there's some similarities. We have not endeavored to try to do some side-by-side work there, but to the extent that some folks are using that Fed standard 791D, there might be some interest in getting some correlation between them. I know for the Hegman gauge, we have done some work there, in terms of trying to correlate to some of the Hegman studies that haven't been complete. There's been some air bubble issues in some of the Hegman study preparations, but I know we're continuing to work on that. So the looks like the particle sizes are a little bit different. We could probably take two of our numbers here and kind of compare them to the 25 and 75. I think it would be pretty close, to what you have here. So so thank you, David, for sharing that. I also see another question about moisture, and it says, what ppm of moisture is permissible for fresh lithium and lithium complex greases? And I think the challenge here is, since no one has been measuring it, there's very little data to correlate what the moisture levels are and what kind of impact they have. I know I was working with SKF in their wind division, and they made a comment that from a bearing perspective, that they were looking for greases with moisture levels below 600 ppm to minimize the damage. And this was based off of their bearing wear studies. These are large bearings, are typically heavily loaded, and so on. But it does give you kind of a reference there. Now, you'd be hard pressed to get to those levels in a lot of the greases that I've looked at. But that's from the end user. That's from the OEM whose components are being lubricated, coming back and saying what they're driving towards to minimize the damage and to extend the life of those very expensive assets. So I don't think that applies across the board, but it gives us some reference as a starting point as to what level of moisture starts to have an impact in some applications. You also look at research, like I like to look at the work from the University of Twente in Belgium. I think it's Belgium, might be the Netherlands, but Pete Lucht and his team, and they've looked at a lot of the effects of moisture on greases, and some of the calcium sulfonate complex greases, up to maybe 8,000 so ppm, 10,000 ppm. Very little impact on the formation of lubricating films and what that seems to do to to greases or to machines lubricated with that kind of grease. So there's no one answer for that. It is dependent on the formulation of the grease, which you kind of put into your question there, Shale. And I think it also depends on the application of the bearing or gear that's being lubricated. But I think we'll get closer to understanding what those limits should be as we see wider adoption of testing of new greases and in-service greases to know what we typically find and start to correlate that to what we see in terms of the wear levels and the life of these components and how they might vary based off of different levels of moisture and particulate. Any more questions? I think that I covered the ones that I saw here during the presentation. Yeah, so good. So, Chris, any last thoughts to leave us with?
I actually had a question for you, if you don't mind.
No, please.
It's been a little time since I was out there at MRG, so I think this is a newer generation of grease analysis device than what I had seen before. I think the one I remember, it measured the amount of force required to push the grease through to kind of build a graph to give you an idea what the particle count might be. So nowadays you can actually get a more clear particle count with the visual analysis.
Yeah, so the ASTM standard D7918 has kind of come in two phases. The first one had four different tests, and it was the dye extrusion that you just mentioned for consistency changes of the grease, a ferrous test to look at the accumulated ferrous wear, and then I think it also had the ruler test in there, and perhaps an FTIR. So it had these four tests, and then more recently, within maybe about three years ago, there was an update to the standard that added two more tests, and that's the moisture by this oven method and a humidity sensor method, this Vapor Pro I mentioned, and then this particle counting. So we haven't really changed the device too much. All the things that were there before and that you had seen and familiar with are still there. The dye extrusion was there. And you're right, we were trying to look at the dye extrusion graph. And if we had a lot of particulate, you could see little spikes in the pressure profile as the grease was extruded. But I don't know that it was really that quantitatively reliable. You could say, wow, there's a lot of that, and this must be a pretty dirty grease with a lot of particulate. And that's as far as it went. Now with this method of being able to create the video profile, to do the image recognition software, to identify the particles, and then to create that size dimension, the major dimension, and the shape of the particle, and then count them and put them into these bins of greater than 10, greater than 25, and greater than 80 microns. We now have a numerical system, a numerical scale that we can use to identify the cleanliness, to create criteria against that might link up to how machines perform when they get too much particulate there, and then hold our greases accountable and our suppliers accountable and our own internal handling methods to make sure we're delivering these clean greases to our machinery. So yeah, Chris, this is an expanded capability of the grease thief analysis methodology, and we now have 10 different tests that can be performed with that 1 gram of grease in a grease thief, including moisture and particulate counting that we shared today. So yeah, thanks for that question. Werner does have a follow-up question here. Can you do a hot plate test, a Crackle test for moisture and grease? And my answer is going to be no. The reason a Crackle test works well for oils is that when you just think about when you're cooking something on the stove, right? You put a pot of water on the stove. Where do the bubbles form? Well, they form down along the bottom where the heat is applied. And then you'll notice when they get big enough, they start to make their way to the surface. And they can make their way to the surface because of that low viscosity of the fluid, the buoyancy of the air bubble, and so on. The problem with grease is when you apply heat on, it'd have to be a really thin film, I believe, and then you might get a gross indication of moisture, but you would never get it to the kind of reliable thresholding values that we like to be able to create some criteria for. So I don't want to say that you can't do it, it'll never work. There's just concerns about when you would get a negative test, just how much moisture could be there, and yet you really don't get this kind of crackling effect. It's not the same as using a liquid oil And I think there's a lot of variables that would maybe impact the confidence that you would have from performing that test. And I did see David mention that he's tried that with I guess, what do you say, a soldering iron? Yeah. And so you get a real thin layer on there, and maybe you can see some popping. But again, it could really vary as to what that meant, what that threshold was, and just how much moisture you're identifying with that. Again, quick test in the field, perhaps. But I'd certainly want to be able to follow that up with something a little more trendable, something that I could create a criteria for and know where I am relative to that. So I think we covered a lot here on grease cleanliness and some tools that are available to test it, and maybe open some eyes about what this could be meaning. I'd like to see some follow-up going forward, which is to now equate these levels. Now that we have measurement capabilities of moisture and particulate, start to create these relationships like we know so well on the oil side, which is if your particle count goes from this to this, what does that mean about the life of that bearing? Or your moisture level goes by this much. There's some tables that have been utilized to help predict how much life extension do I get out of having cleaner oils. And I believe that information could be derived for greases. I think that's just where we take this next and take it to the next step. But the first step, of course, is knowing how clean are your greases. And so I want to thank Chris for joining us here today and for allowing us to come to his facility and kind of open his doors and share with us what he has there. I'd just like to say how impressed I am with the work that they've done. Chris and Travis Sanderson have been at this a while now, and they've taken this knowledge about lubricants and really put it to work in their facility, which, by the way, if you don't know ES3, it's one of the, if not the largest automated warehouse in the world. It's quite an impressive facility that's bringing food to the people of our region every day. And they're doing so reliably because of the commitment of folks like Travis and Chris Orr, who joined us here today, and how they recognize how important lubrication is in that function. So, Chris, thanks again. Thanks for joining us. And Marissa, what do we have on tap for next time? We're going to do Grease Thief next month as well, Grease Thief Thursdays. What do we have coming up?
Yes. Next month on October 21st, we have another Grease Thief Thursday. We're doing analytical photography, doing part 2 analytical photography and looking at case studies. So we will have a special guest, Ray Daly from Trico, over here again to discuss analytical photography and look at some case studies.
Hey, that's great. Ray joined us a couple months ago, and it was fantastic. And we used this format to be able to send the video signal right out of the microscope. And so live, we had Ray looking at some of the particles and commenting on them. And I think it was really valuable for anyone who has an interest in analytical photography. So it's exciting to get into that again. Thank you for Marissa for setting this up. Thank you for Chris Orr of ES3 for joining us today, and for everybody who participated and asked questions. It added a lot of value, and I appreciate that. So with that, we'll sign off, and we'll see you next month. Take care.